Hey guys, so welcome to High Entropy and let's begin without wasting time. So it's day 98 and yesterday I haven't streamed but I was solving the problem. I will tell you a quick story. So on Sunday I went out uh, and then I decided okay, tomorrow I'll maybe like on Monday I will wake up early. But what happens in the night there was power cut like for 2 3 hours. So I thought okay, I can't sleep if there is a power cut and no fan is running. So I thought okay, no problem. What I'll do, I will watch some content. So I thought okay, why don't I start a revision of the dynamic programming? Then I solved two problems. So I already did it. I never broke consistency, but yeah, I haven't streamed it because of power cut and all. So let's begin today. Without wasting time, I'm so late, but I have to continue it without any break. So let's do it. I'm solving the graph problems, and right now I'm sharing my screen without any problem. Juggling meaning. Frog jump, you can see. DP series, let me stop it. Speed test, not needed. And anything else? So yes, on BFS number of enclaves, we need to solve it. So DFS and BFS. So okay, given an n cross m binary matrix where 0 represents a C cell and a 1 represents a land cell. A move consists of walking from one land cell to another adjacent 4 directionally. A move consists of walking from one land cell to another adjacent land cell or walking off the boundary of the grid. Okay. Find the number of land cells in the grid for which we cannot walk off the boundary of the grid in any number of moves. Okay, so basically we need to find out all the number of land cells in the grid for which we cannot walk off the boundary. So here you can see 314. No, 3, because these 3 cells we cannot go. Okay, wonderful. Why do I feel like I haven't solved one of the problem? This one. Submissions 31st July. Which one I forgot? I was not able to solve one of the problem. Detective cycle distance of nearest cell having 1. Somewhere I found one problem surrounded regions, I believe. Yeah, this one. Yeah, this one. Actually, I failed it. Failed to solve it. Okay, I'll do it later. First, let's solve a fresh problem. Number of enclaves. So, okay. So basically, we need to find out all the cell that from which we cannot reach to boundary. Okay. So what would be the approach here? One option is you have to start from each cell and you can traverse like whether you can reach in all 4 directions. That is very intense computing process, so we don't want it. So basically what I am thinking, why don't we start from the boundary cells where the boundary where 1 is present, and from there we can look for the cells that are reachable, something like that, a reverse process. Basically move to all the cells that you can reach, and if it's not visited then mark them visited. Hmm. Zero, just mark them blindly visited, so you don't need to travel, and all other cell that you can reach. For example, here you can say from here you can reach this, it is already filled. This one you can go, so remaining three. They haven't given any proper example, but I got the idea for it. So let me save my screen and let's discuss about this thought process that about the problem. Let me jot down the problem. Note down, I mean. How many rows? 4. How many columns? 4. 0 0 0 1 0 0. Okay, just imagine. First thing, we need to find out all the cells from which we cannot reach to boundary. Boundary cells are these. These are the boundary cells. Okay, the last row, last column, first and last row. These are the boundary cells. And here, if something is 0, that means you cannot reach. Obviously, that is blocked. You can think of, and you need to find out 1. So here you can see this is 1. So if someone from the out inside want to come out, definitely should be able to reach here, this cell, correct? Then only you will be able to reach boundary. From other sides it's filled, so you need to check. Okay, so what you can do, like from this cell, wherever possible, what are the reachable possible cells that you can reach. From here you can see you cannot reach here, here it's blocked from all sides. Then all other cell you don't have to check, because that means you won't be able to. So my thought process is simple. Here what I'll do, I will simply create a visited array, and I will start DFS or a BFS, you can apply anything. So whatever the cells that are already been there and that has been, basically what you can do, mark them visited, zeros, because these are the cell you don't want to access them, right? For example, 1 1 1 1, so you don't need to visit them. And all other cell, just mark them, like all the cell zeros, mark them visited. So step 1, mark all zeros as visited. Just we don't want to process them, that's why I'm marking them visited. And all other cell, okay. Then whatever the cells, step 2, if boundary cell has value 1, then push it into queue. Okay, and now just start basically looking for all the neighboring cells that are not visited, and one by one pull. Step 3, pull out from queue one by one or you can say just apply BFS or DFS. If you are using Q, then that means you need to apply the BFS, and if you wanted to go with DFS, then you have to just apply DFS on each cell, each non-visited cell. So basically you need to track them. So what I'll do, I'll use simply BFS. It will be easy to apply here. So let's do it quickly. वास्ते को मैं हुई यहाँ. I just read it. I mean, I watched videos, so that's why I'm saying. So first thing is we need to import from collection. From collections, import Q. Import deck. TQ. Second thing, just we need to m len of grid, number of rows, len of grid of 0. Okay, so we got rows and columns, number of rows, number of columns, and visited we need to mark it visited. Keep it everything 0. Sorry, first we need to create it just 0 into n for underscore in range m, and this is one thing. Now for I in range m, for j in range n, if okay, let's create the DQ so that we can post through a DQ deck. If grid of I and j equals to 0, so visited of I and j equals to 1. Okay, another condition, if grid of I and j equals to 1 and it is boundary, so and will say I equals to 0 or j equals to 0 or I equals to n minus 1. Sorry, I will be m minus 1. First row this one, and last row it's better if I use this way, first row or last row, or I j equals to 0 or j equals to n minus 1. So if these are the conditions, then what you will do, simply dq, post it into dq dot, not post, append what needs to be appended, I and j, bro, that's all. And now just process, apply BFS. So while dq, so you can say I and j will be nothing but, here you can say you can say dq dot append, dq dot pop left, sorry. Okay, so we got I and j. So it will be, I'll just simply tell you what exactly we are getting here. So we have first we did all the ones in the boundary condition, we post them into the queue. Now we are processing one by one. So we are popping out one by one from the queue, first in first out way. Now for each one we need, for example, if you are here, so what are the possible moves for you, here or here or here, but for any cell that is in the boundary condition or somewhere. So okay, so but let me note down moves as well at the top. Moves are different moves for it. So it could be, you are going from, okay, so you can go 0 to 1 and 0 minus 1 1 0 and minus 1 0. So these are the moves. For move, in moves, okay, so x will be I plus move of 0 and y will be j plus move of 1. And now just need to check if it is not a boundary condition. the move is possible, feasible move. Correct. For example, if you move this direction, that is not possible move. If you can say x greater than equals to 0 and x less than m and y greater than equals to 0 and y less than n, then simply you can move it. Basically this is a perfect move. So dq dot append, basically you can append it. So for example, from suppose there is a adjacent neighbor of it or one, so you can push it and now you have to process it like what are the possible move for it. So you can say x and y moved. And okay, one thing I just forgot to tell, when you are visited of I and j equals to 1 here as well. Now visited we have calculated. Okay, what else we need to do? So whenever you are appending something, just mark it as a visited of x and y is equals to 1. Okay, this is done. Now just we need to check what are the non-visited cells, that means not non-reachable. So count, just mark count equals to 0 for I will copy it because we are going to perform the same operation, not same operation but same loop we can use. So if visited of I and j equals to 0, count plus equals to 1, it means non-reachable cells are there, and return CNT. It's simple, I think, simple solution problem. 11 hours ago I just submitted, I don't know why. Why? Killed. I mean, is it taking time? What's it? Greater than equals to 0 and zero zero 1 minus 1 1 minus 1 0 0. What's wrong with it? Let me copy, do one thing. It is giving me weird. So the problem is here. While loop is running for longer duration, I believe. dq dot append IJ while dq IJ dq dot pop left for move in moves x equals to I plus move 0, and if x greater than equals to 0, x and y visited of x visited of y equals to 1. Man, what's wrong with you? I just want to see. I make mistakes so many times. 1 and 0. I did some mistake, that's why it is showing. It's killing the process. Is it running for infinite time, bro? So, DQ. Z equals to 0. For move in moves, oh, I missed one thing. For sure. It is like only we can move it. Sorry. The main point. And oh, okay, grid of x and y equals to 1. Then only you can move, bro. So sorry. Fuck. Simple thing I missed. What? Oh, okay. Visited x y. Where is your brain? Fuck off. Simple problem you are not able to do it, bro. What's the point? The point here. This was a simple problem. Simple, dimple, very simple, very simple. Dimple, very simple. So just let me check. 23 minutes took. Bro, word ladder. So before I jump to word ladder, why don't I try out this problem one more time? Maybe new day. I will come up with fresh approach. I don't know. We can try out, right? What are you gonna? Oh, this is the one problem. This is the problem that I took long time to understand. Only the problem. I mean, I took a lot of time to understand the problem, and then I failed it because I was completely. You are given a matrix of size m n cross m where each cell contains either 0 or x or x or x. Oh, there is ORS, not ORX. Your task is to replace 0 cells that are completely surrounded by x with x. An O or group of connected zero O's is considered surrounded if it is not connected to any border of the matrix. Or let me think about the approach. Maybe I need to think it from fresh up mind. So that means we need to look for all the central pieces, central O's. So what if I'll push these all boundary O's and I will check whatever the cells that are reachable from these O's cannot be hmm, all the cells that can be that can be that are reachable from these boundary cells, boundary O's, and the cells that are not reachable from boundary are won't be. Okay, let me try it. Earlier I was using a different approach method. Kattam Kuttam, I think we call this game. I don't know what you guys call it. How to say it in English? Katam Kutam. I'll just search it. What is the name of the game Kattam Kuttam? Name of I don't know. I just know Hindi. English name of oh knitting game. Images I will check. Oh Ancho. I know it. Tic Tac Toe. I heard it. I mean I heard it, but I wasn't aware that we call it. I forgot the name. Actually, I read it so many times. And knitting game. It's showing Telugu detected. Kattam Kuttam. It is showing, see, Kattam Kutham game. Okay, I'll search Tic Tac Toe game in Hindi. Zero Kata. Oh. Tic Tac Toe. It's not a game, but looks like XXX. So many X. I think Elon Musk uh, solved this problem, and after that only he thought to change the name of. Sorry, I'm just kidding. So what I'm thinking. Oh, sorry, I have to say. So for example, whatever the O's are there, let's say this one is also O. So what we will do simply, if something is in the boundary, that means whatever the values that are accessible from it cannot be changed to X, correct? And all other values that are in the center part can be changed. So we'll mark whatever we will do. First thing, all the X. Okay, I'll write down the steps. It is better. Step one: create a visited and okay, create a visited array. Step two: mark all X as visited, and also, and if it is boundary and O, then push it into Q. Okay, now just start applying, start BFS and mark all accessible nodes as visited. Okay, and at the end, whatever the non-visited nodes are, just turn them into X. I think I'm doing something wrong. This will work, but output, I think I won't get output. Okay, what we'll do, we'll also create result array, and every time, like, you are differently, you are just processing O's, right? O value. So like when you will create, all the X will be there, all the O will be there, and all other remaining part will be like that are visited and will be there. That are not visited. I think we don't need to. No, I'm just thinking we don't need to basically we need to create a result array, but we can process it at the end. Simply what you do, at starting only, when you are processing, just mark all the x's into, push them into this array, and also push them the queue items as well, and all other items that will be visited, uh, that are being visited by this queue, will mark them as a, okay, let's do it at the time only. So mark them as O, and at the end whatever the non-visited will be there, mark them as X. Hmm. What was my old approach? If matrix of X, I was appending X. Okay, buddy. I was doing reverse process. That was wrong. So I think that's what. First thing, step one, just import from collections, import tque tech, and tq tech. I will create it. M is len of mat, n is len of mat of 0. So we got m and number of rows, number of columns, and now we will create two arrays. Visited will be 0 into n for underscore in range m, and another one result. I will keep it same as it is, but we need to override it. So what we will do, let's say iterate for I in range m, for j in range n. Now if, first thing, if matrix of I and j equals to x, simply visited of I and j equals to 1. Another thing, result of I and j equals to x. Okay, sorry, I'm assigning, right? Okay. Another thing, if mat of I and j equals to O, and another thing, it is I equals to 0, or I equals to m minus 1, or j equals to boundary conditions you are checking 0, or j equals to n minus 1. If any of these conditions satisfies, that means this one should be pushed. dq dot append I and j. Okay, so you post it dq dot append, and you mark it as a visited of I and j equals to 1. So you got visited, you marked it visited, and you post it into queue for BFS, breadth first search operation. And another thing that needs to be taken care, what is it? A result. We need to add it into result of I and j equals to O. Okay, so now we covered like all the boundary condition, all the x are there. So at the starting you will see this one, all the x will be there, this O will be there, and for all other what we need to do, Now while dq, so I and j will be here dq dot pop left, and now one thing, dq is sorry moves will be 0 1 comma 0 comma 0 and minus 1 1 and 0 1 minus 1 and 0 0 1 0 minus 1 1 minus 1 0. So these are moves. Now you will say for move, in moves, and you will say x equals to I plus move of 0, y equals to j plus move of 1. So you got move. Now the thing is, simply you need to check. Suppose you are somewhere here, you need to check if, first thing, check it is if it is within the boundary. if 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 first thing, just check if I no x greater than equals to 0 and x less than m and y greater than equals to 0 and y less than n and not visited. First thing, if it is visited of x and y, and another thing, x, okay, definitely if it is not visited, then it is, we don't need to check that condition, because all the x's are there, all x values are already being marked as visited, so you don't need to check. Okay, so now this is one of the item that is accessible from this location, correct, from it, and it is O. Okay, so what you will do, dq dot append, you can say x comma y and mark it as visited, x y equals to 1. Also result will be, this node won't be changing because it is connected to boundary xi equals to O. So okay, and now what you will do, so this is the condition, and for at the end what you will do, just need to process for I in range m, j for j in range n, if not visited I and j. If it is not visited, what does it mean? It means it is not accessible from boundary. So these are surrounded by x, so you can mark it as a visited. Result of I and j is equals to x, and finally return result. Oh, visited, visited not defined. Where did I do? Where did I create visited? Crazy, bro. I remember I make lot of mistakes. Ooh, wow, perfect, wonderful. Last time I was not. Sometimes taking break is also efficient. I don't know. Maybe the last problem helped me to think out of in different way. But wonderful. Two problems. That time something is wrong. I'm not getting it. What? Let's do. I mean, it's 22. Oh, what the heck? Why are you saying? Oh, Guys, I don't know. I'm not never seeing this stream. If someone is gonna let me check once. Is anyone watching? Oh, guys, I don't know. I'm not never seeing. Hey, bro. This why I'm not looking. Not let me check once. Is anyone watching? Oh, guys, I don't know. I'm not never seeing. Hey, bro. This why I'm not looking. Not let me check once. Is anyone watching? I'm not looking chat. Leave it. What does it mean? Just looking? Ooh. Guys, hey guys, just watch reels like me. I have started watching shorts videos today. Very bad. Why don't I solve one more problem? Because nowadays you cannot. Oh, you cannot act like a woman. Oh, my English is not going to improve. What the heck? Word order. Word ladder, not word order. Okay, why don't I solve it? So just give me a few seconds. I want to watch few reels. Just give me 2 minutes. Let me get some temporary motivation. I will change my screen. Okay. I don't know what I am doing. Hope you cannot see. Where did you get the data? How many men? The judge. Right question to wrong people. What you said. Live stream from Jharkhand.
प्यासी प्यासी मर जाऊंगी ऐसे मुझे ऐसे
Guys, do you want to listen this? Let me. You can listen it, right?
आजा तुझे है बन दिखाऊंगी
I don't know. I don't know what to do.
प्यासी प्यासी मर जाऊंगी ऐसे मुझे ऐसे तड़पाना ना कर
You understand, right? Let me show you.
नजर से नजर आजा तुझे है बन दिखाऊंगी
I don't know why I watched it so many times.
प्यासी प्यासी मर जाऊंगी ऐसे मुझे ऐसे तड़पाना ना कर जरा भी फिक्र मिला मिला नजर से नजर आजा तुझे है बन दिखाऊंगी
I don't know what to do. I don't know what to do. तौबा, आगे क्या करूं?
प्यासी प्यासी मर जाऊंगी ऐसे मुझे ऐसे
I like this step.
तड़पाना ना कर
This is the best one. This one. This one. I don't know about you. If you want it, you can comment it. Maybe you haven't watched, so you won't get it. Okay, let's forget about it. Let me actually what I'll do. I'll minimize it and let's focus on another problem. Hard, really? Given given are the two distinct. Given are the two distinct words start word and target word, and a list of size n, denoting word list of unique words of equal size m. By the way, what is the time length stream duration? Oh, 54 minutes, no problem. If I'll get late to wake up in the morning, then I'll say I'm sick, I cannot come to office. This is the best excuse whenever you don't want to go to office. Bro, try it if you are a working professional. Given the language is little difficult for me. Given are the two distinct words Given are the two distinct words, start word and target word, and a list of size n, denoting word list of unique words of equal size m. Find the length of the shortest transformation sequence from start word to target word. Keep the following conditions in mind. So basically, we need to find the shortest length to transform sequence from start word to target word. Okay, a word can only consist of lowercase character. Okay, only one letter can be changed in each transformation. Okay, in each step you can change one letter. Each transformed word must. By the way, I'm just thinking like, is it just one way graph only? Concept of lowercase, only one letter can be changed in each transformation. Each transformed word must exist in the word list, including the target word. Ooh, okay. Start word may or may not be the part of word list. If there is no possible way to transform the sequence from start word to target word, return zero. I got the I got the question at least. Zoom to 100%. Word list is DESDER another DZD and what DFS. Okay. Okay, so unique words of equal size. Perfect. So that means every time when we are transforming a word, it should be in the word list except the first one, second, even the last target word, because that is also the result of transformation. And we can change one character. Only one letter can be changed in each transformation. Wow. So start word is DFS DFSH. No, DER. Der. DFS. What the heck, guys? So our goal is to reach from mode to melody. I'm sharing my screen or not? I just wanted to check when. Yeah, perfect. Because that is very important. Otherwise, it will be of no use. Sorry, this is just jokes apart. Oh, Josh Rodia. What is this roadmap by Josh Radia? I'm so sorry if I'm pronouncing it wrong. Radia. Okay. Smallest transformation sequence from D. So D to okay. So we don't need to change D. E need to change from E to F. E to F can be changed. DFR. Yeah, so we can change DFR. DFS. So this is the transformation, and then R to S. So we need two transformation. Output 3. E replaced by R. Three different strings for us to reach the target word. Each of the strings are present in the word list. What? But why are you counting start as well? Start word to target word. Okay. Geek and EFK. Okay, so now you want geek to Z. ZEFK. ZEK. ZEFK. So ZEEK will change E to F. Okay, so here just we need to change GEK. Just change D to E. Okay, but what is the approach for it? Okay, I don't know how will it fit into a graph. If I don't know, then how would I be able to solve it? Okay, one thing I'm just thinking. Basically, it's a kind of thing where we are just seeing one change in the word. For example, DES. Just I'm trying to draw a graph for DES to we can go to DER. Correct. Just we need to change R and S. And DFS to DFR. This is when oh DJF or DGT and DZT. This one covered. This one DSDER covered. DZT covered. DZST. No, DZT not covered. DFR, DFS, and DZT remaining. And here you can say DFS. You can say this one transformation can be done, and from here you can say DER, DFR. Okay. So it is like here you are getting DER, and now you need to reach to DFS. So shortest path you need to find DFS. You will try this option, you will try this option, then you will reach to this, and you will get one step, two steps, so total three. But how to build the graph? GEK, GFEFK, ZEEK, GFK. Now, bro, I need more examples. Then I might get hot, dot, dog, lot, log. Hot and dot. Another one is dog. Another one is lot. Another one is log. And okay, start is hit, target is cog. Let's build. So we have hot and we have dot. So if you see hot and dot are connected, there is only difference of D and H. Okay, dog. If you see dog, here DOZ, only the difference is G and T. Okay, lot. So LOT, lot, and log, LOZ, and this is also connected, log and dog. Now you are somewhere, all these words are connected to each other. Now somewhere you are hit, and you want to go to cog. Cog is not in the list, so you can return directly minus 0, not 0, 0, 0, 0, 0. Correct. But what if we wanted to get from hit to heart directly? Hit to dog. Suppose you wanted to go to hit to dog here, then this step, this one, 2, 3, 1, 2, 3, 4, total 4. From here to here, here to here, here to here. Whoa. Or you can go from here to here, here to here, here to here. How many steps? 1, 2, 3, 4. 1, 2, 3. It is taking more time. 1, 2, 3, 4, 5. No. 1, 2, 3, 4. 1, 2, 3. 3, 4. 4, 5. Oh, sorry. I was not sharing myself. So main important point is here to build this word to how to construct it. HOT. So its adjacent will be okay. For hot it will be lot and dot, lot dot, and for lot and dot also it will be hot hot. Another thing, hot and hot, you covered hot, dot and lot, it will be dog. This is a small word, but what if the length of word can be very long, right? Right. Word length can be 100 character long. Perfect. And words list can be up to 10. That is a small one. How to compare? That is the critical part where you need to compare the word and you need to find all the words that are matching with it and only has one character difference. And for each word you need to basically hmm, so each word we need to find step, most important step, build graph for each word, find its neighbors, and finding its neighbors means there is a word and you need to check all the different words, compare it with those words. I'm so bad at it. Maybe what I'll do, for each word there are 110 only words listed, 10 words, so that means 10, and for each word you have to perform operation to, so 10 into 100, correct? I mean, for each word you are going to compare by basically by character count the number of characters that are different. So this is one option. And then for example there is a cat and dat, so you will start comparing one by word because length is same, so you will say okay, this is one count, this is one count, and whenever okay, so this is different, so c and t equals to 1, you will say oh, when matching, count will remain same, and if count you are getting 1, that means it's true, so this is one of the neighbor. And simply what you will do, so cat will build adjacency list only for cat, different words, for that also you will add into and then you will compare. What you will do, basically you will source. So you will find all the adjacent of source, and then you will come. Okay, you will do one thing. So source, and you will start from source only. Okay. See, my titles: confusion, phrases, grammar, brainstorming. My brain will never storm. I'm kidding. I think I'm near to approach, bro. Very fantastic. And most important thing is, I know I have to think in a. It's like you are make a made up. What we say in English? Well, frog. Mm, Well's frog. Frog is frog in the well. Yeah. So, koop manduk in Sanskrit. I heard this word. So yeah, right now whenever I'm solving a problem, I can think like, okay, this is a graph, so I have to think in the terms of graph. But when you it will be random, you are getting it. Then you have to think out of box. It could be that's why people are nowadays more focusing on the they are more focusing on different different patterns. So I watched a video. He was telling there are 28 patterns. So I have to master them because otherwise you end up with confusion and all, because whenever you are solving a problem you have to scan through, can we solve it using binary search, can we solve it using, and some of the patterns are easy to detect. For example, if it's related to tree, you will get until it's some hidden tree here, but it's a hidden graph. It is not directly mentioned like, okay, this is graph kind of problem. So you might end up with something like where you will try to solve it using different approach. But I am giving gyan, even I am not yet near to the solution. How to. Okay, okay. Let's do one thing. Oh, now step. Write down the step. Then we'll solve it. So steps. Step one: build adjacency list. Now here I'm confused whether should I use words in the adjacency, or shall I create a mapping for each word assign a number. Maybe 0 represents uh, SRC word, and so on. You are at 0 node. Suppose you want to be reach to ninth node. Then what you will do? So you want minimum distance. You need to reach this. So you will do, basically you will push all the neighbors and along with the distance, and then these neighbors will try to reach to this with distance. And then you will do one thing, you will maintain one minimum distance, and every time when you are reaching target you will compare if you are reaching with minimum distance, and you will update. Okay, so at least I have some approach, but only problem is how to maintain a adjacency list. And I'm forgetting so much quickly. I mean, I forgot the concept adjacency list. I have to recall it, or maybe I will solve, then only I get it. So list of dictionaries, dictionary of list. Yeah, let's do that. So step one, build adjacency list. So word list. No, bro, list. Okay, let's do one thing. Compare word. Compare word. So here we'll do uh, self word one. Why I'm getting word one, word two. So these are the two words. What we'll do for uh, I in range len of word one, and here I'll come cnt equals to 0. And if word 1 of I equals to not equals to word 2 of I, that means words are not equal, characters are not equal, that means count plus equals to 1. And at any step phase where you are getting, if count greater than 1, return false. At the end, return true. Somewhere if you are getting, what does it mean, true and false? That means both are neighbor, or you can say you just need one transformation to reach from one word to another. Okay, So we'll just say adjacency list is equals to, it's a dictionary to be honest, dictionary of list. So first we'll build for all the words list. For word in word so we are getting a word. How do I start it, bro? Ah, sorry, I forgot it. So we need to start it like this. For each word, I mean, yes, not like this. For n will be len of word list. Okay. Now for each word you will say I in range n, and here for j in range I plus 1 to n. What exactly we are doing? For each word you are going to compare with all other words. If compare word, oh man, compare word, what do I say? Word, and word 1 will be word of word list of I, and word list of j. If both are equal, then what we will do? If word, okay, let's do one thing. Word 1 is equals to word bands show word, I will copy it, bro. Compare, and now what I will do, we'll check. First thing, we need to basically word 1 is relating to word 2, so both should be part of for word 1, the for this node this will be part of its adjacency list. So if word 1 in dict uh, adjacency list, so if it is in the list, then what you'll do, it means the key is already exist. So adjacency list dot append adjacency list of word 1 dot append word 2. If okay, one thing I'll do, I will add word list, this one also, word list append start word, because yeah, we want to build the adjacency for this one as too. So why would I'm just thinking in that way. I don't want to pre-process it. Let's see how, will there be any problem if I'll build this adjacency in that way? I don't think. Maybe I'm not sure about it. So this is for this one. Now else, What you'll do? Adjacency list of word 1 is equals to word 1. So you are just appending a list, word 2, sorry. And same for this one. If word 2 in, okay, let's do one thing, just copy it. Option, arrow down. Oh, sorry. Simply what exactly we are doing? We are basically adding word 2, word 2, word 2 dot append word 1. So A is part of B's adjacency list and B is part of word 1 is part of word 2's adjacency list. So finally we'll build the adjacency list. Now next step is, once it is built, not build, build. So now the next thing is we need to process it. So let's do one thing. From collections import, I mix lot of tech collections import tech. So next step is dq dot dq equals to dq dot append also. I will do one thing at the starting only. If word, if target word not in word list, simply return 0, because yeah, we don't need to process it anything. dq dot append, simply what you will do, you will append do we need to create wasted array or not? I want to optimize it, bro. Why don't I use the indexes of the list? We have word list. Yeah, I'll do one thing. Instead of creating this all the handling with words, let's do one thing. For first thing I will do, I will do this. Then also this. So for blank string we are going to create for underscore range n. So this means all the index will point to word list character. I in range, J in range. Word 1 will be word list of I. Perfect. Word list of Z. Correct. Now why do we need to, if word 1 in adjacency list, Simply, what does it mean? Word 1 is nothing but I, and append j. Also here I and j. How cool it will be. I mean, I for instead of z, simply you will say z, and I. Even you don't need to do this all bullshit. Just add this like this. What you did, bro? This is done. And now we got simple, short, and sweet adjacency list. DQ. What we will do? We'll append starting. So it is the last one. If you notice, so you can say n minus 1. And what is the node transformation step? You took 1. And just let me create target index plus 2. Uh, target index, target node is equals to minus 1. I for item so word list append target node, find the index of target uh, in word list. So for there will be simple approach, right? But let's forget about it. For I in range if word length, bro, I always use word length list of I equals to target word. Target equals to I break. Finally, we got it. Okay, we got this. So we got target. And now what we'll do? DQ dot append, and we'll mark visited array. Visited will be something like 0. Oh, I will do it like this: 0 into n length of 0, and DQ dot append. Sorry. It should be part of this. It's q DQ dot append. First item you are appending, and also you will mark visited of n minus 1 equals to 1. Target will be here n minus 1 1, And okay, so let's start processing it. I'm excited for it. While DQ, so we will get two things. So let's say something target, what do we call it? So node and length, let's say, yeah, length L, we'll call it, and it is like dq dot pop. Basically we are popping pop left. I feel like I'm just something wrong. So node left. Okay, we got this. Now we need to find out all the neighbors of it. First thing, visited already, it's visited, so you can say src. I'll call it src better. Src is equals to n minus 1, and you can say src equals to 1. Perfect. Now every time we are getting this node and left L, we pop out the item, and next step is oh, it's 326, bro. So how much time I'm taking to solve it? Let's not forget about the time. First thing is solve it. So we got the item and we pop out, and now we need to look for all the neighbors. So then we are in adjacency list of node, so all of its neighbor and whatever the neighbors that you are getting from it, you need to, if not visited, nbr. If neighbor is not visited, that means you are visiting for the first time. Then what you'll do, simply dq dot append. Basically you need to append it, so it's neighbor of the src, right? So append, and what you will do, simply append, and here you will say count equals to max count, max cnt equals to 0. So, or you can say max len equals to 0. So this is global result that we are looking for, and every time what you will do, dq dot append. Okay, one thing, if node equals to target, simply what you will do, you will add max len is equals to max of float of max of max len. Also you are getting something L, so this one will be there. Okay, one more thing, dq dot append, we appended the item. I take a lot of time, not visited, append. So you will append nbr and L plus 1, because you are taking one more step to transform to this another step, so L plus 1. Okay, you will append it, you will mark it visited, bro, nbr equals to 1, and finally return if. Basically we need to check if you are able to reach to that location target or not. Even if max len, I'm just checking, max len equals to float of inf, simply return 0. Max len, I don't know why I use camel case here. It's actually they are also using camel case, so I think I made mistakes here. Compare word is not defined. As usual, I expected. But let me check if it is also even word. I create Compare word. Okay, so self dot compare word we're going to use. Word to I set where I use word. My typing is very bad. I make a lot of typo mistake. First, let me confirm if this is working. Oh, it's accepted. Why every time I'm getting zero, भैया? Oh, main culprit is target. No, no, no. Yeah, yeah, yeah. Sorry, I need to check it after it. It's not a culprit. Print word list source. Target word, so 0, 1, 2, 3, 4, 5. Target DER 0, 1, 2, 3, 4, 5. 5. Yeah, but the target is DFS, bro. How is possible? Okay, one thing I need to do. If DER is not in the list, we need to append it, and we need to find the target. Because here I can see DER is there already. If target is not in the list, sorry, source, start, append it. So I'll do one thing. Found equals to false. If we start word, equals to word list of I, then found equals to true. Break. This is one condition. If not found, simply what you will do, basically word list dot append, and you will add start word. Okay, so this is one thing. Word list dot append, word list append, start word. Okay, I'll do this we can remove it. Now only thing is we need to find the print adjacency list here before target in the word list. Target and source in the word list. If word list of I equals to start word source equals to I just need to change start better. Or let's keep it, no problem. Source is equals to I. So word list, and let's see DES start word target. Our goal is target word is DFS. Something is wrong here compare in the comparison. Source target, well, how can it be? Source is 4 and target is 1. Zero, 1, 2, 3, 4. DFS. So you got source and target DER 01. Why do I feel like target they have given source as start word DFS and target word DER. In the second example, start word ZDK, target word GEK. ZDK, ZEEK. Here we see ZDK 2 is the start source, okay, correct, and this one 0 ZEAK. Here at least the numbers are correct, but in the first one start word DFS. So DFS 4 correct. Target DER. So DER is 1 correct. So word list is correct. at least based on this. For 0 DES. Okay, so we got this adjacency list. While DQ dot left. What was wrong? Here if I'll keep max, then I was keeping 0. It was okay, right? I don't know what, something. God. I think I made a mistake starting only the. Bro, you have to do something. Print. 1, 2, 3, 4, 5, 6. It's so very interesting. To be honest, I thought I need to watch Solution. Bro, you can do it. Just have faith on you. Yes, 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 yes. It's possible. Wonderful. So, still, I'm not exhausted to be honest. I'll be back in 2 minutes, guys. Actually, I need to fill my bottle. Either problems are simple or my brain. Today I went for running, so maybe the effect. Sorry, feeling better. I have to go daily now. Boom. Okay, let's stop it. I will watch reels now. Thanks. Let me just check if someone has pinged me. So sorry if you pinged anyone. I can't believe. Why don't you believe? Just believe on you. It's very important. Let me just check if someone has. Oh, sorry. Sorry, bro. ये क्वेश्चन अलग से हो रहा है. Which one, bro? I have to watch. I wasn't watching it. Thank you all. Can I edit my masses? No. Oh, I don't know how to speak, so it's okay. Oh, crazy, yeah.